Thank you so much for taking time out of your busy day to join us for this timely webinar. My name is Dr. Brad Shellito, and I'm a board director with AmericaView, which is a national network of 42 member states and which administers the Remote Sensing States Grants Program throughout the USGS, which is the United States Geological Survey. Now, AmericaView, being a national network, didn't just appear overnight. It all started way back in 1996 out of the state of Ohio with a program that was called OhioView that was dedicated to statewide remote sensing and GIS. But it became clear that a state program was way too good of an idea to just be there for one particular state. And so by 2003, OhioView had expanded its network out to become AmericaView and is now expanded out to 42 states. There is beyond an Ohio view, there is a Texas view, there's an Idaho view. Each one of these programs is what's referred to as a state view. And what I'll be doing here today is moderating the discussion about the work that all of these state views are doing across the country. And they're doing this in order to support American entrepreneurs, to advance key industries and resource exploration, to enhance disaster response and resilience, and all kinds of other stuff that you're going to be hearing about today from our speakers. But who you'll be hearing about here today, you'll be hearing from members of Congress. You'll be hearing from experts in our field across the AmericaView network about the important roles that the Landsat satellite program and that the Remote Sensing State Grants program play in our ability to develop the next generation of innovators and skilled employees and to train the workforce of tomorrow. Our presenters are going to be discussing why it's important for the U.S. to secure our place in the world as a world leader in this remote sensing field. And when we talk about remote sensing, we're going to be talking about taking imagery off of satellites, taking imagery off of planes, taking imagery off of drones, and then more importantly, turning that imagery into actionable intelligence and actionable information that we're going to be able to work with. So anyway, throughout the session, we encourage you to ask questions. You have a Q&A box there here on your screen, and please drop any questions into that Q&A box. We'll have time at the end to answer some questions. And so we'll be able to try and answer as many questions as we can during that Q&A portion. If you have a question for a particular speaker, please shout that out. But your best bet is to use that Q&A box rather than putting something into the chat. Now, we're also recording today's briefing, and we'll be sending the link for the recording out to everybody who registered after the session ends, so don't worry if you missed something. But before we get started with our panel from professors and experts here from AmericaView, the first thing we do is like to share some remarks from four of our congressional champions. Lisa Murkowski, the senior senator from Alaska, Celeste Malloy, who represents Utah's 2nd Congressional District, Dusty Johnson, who represents South Dakota's at-large district in the U.S. House of Representatives, and Nick Begich, who represents Alaska's at-large district within the U.S. House. So first, we're going to hear from Senator Lisa Murkowski. Now, Senator Murkowski is Alaska's senior senator, and since joining the Senate in 2002, she's earned a reputation for her ability to work collaboratively and across the aisle to reach common sense solutions. Now, among her committee assignments, Senator Murkowski serves as the chair of the Senate Appropriations Subcommittee on Interior Environment-Related Agencies, as well as the chair of the Senate Committee on Indian Affairs.
Well, hi, everyone. Senator Lisa Murkowski here. I want to thank you for inviting me to say just a few words at your briefing. And I'd also like to thank Dr. Panda and the University of Alaska Fairbanks for their leadership. In Alaska, we know just how vital remote sensing is. With our vast landscapes and unique geographical challenges, access to timely, high-quality satellite data can really mean the difference between swift wildfire response and devastating loss, between effective resource management and missed opportunities. Whether it's monitoring coastal erosion, improving transportation safety, or supporting our fisheries, or enhancing disaster preparedness, remote sensing is really an invaluable tool. And programs like AlaskaView play a role in making these technologies accessible by providing training for first responders, offering educational programs to young Alaskans, and supporting students in STEM careers. AlaskaView is not only responding to today's needs, but also preparing the workforce of the future. Now, Congress has an important role to play in supporting these advancements. The USGS Remote Sensing State Grants Program, for example, helps train the next generation of scientists and professionals who will continue to harness the power of satellite data for economic development, security, and environmental sustainability. Investing in these technologies strengthens our national security, enhances resource exploration, and ensures that we remain competitive on the global stage. So know that I appreciate all of you for being part of the conversation. Your insights and expertise will help shape the future of remote sensing, ensuring that we continue to unlock its full potential for our communities, our economy, and our nation's security. Thanks so much. Be well.
All right, next we'll hear from Congresswoman Celeste Malloy. Now, Congresswoman Malloy joined Congress in 2023 and currently serves on the House Appropriations Committee. She also serves on the House Natural Resources Committee, where she's a champion of Utah's rights to use and access its rich natural resources and public lands.
Hi, I'm Celeste Malloy, and I have the honor of representing Utah's 2nd Congressional District in Congress. UdahView, which is part of the AmericaView network, supports key Utah industries which matter to me, including agriculture, water management, natural resources management, by making the satellite imagery and remote sensing technology available to communities and decision makers who are key players in the areas that I care about, natural resources and Utah. Since 2010, UdahView's provided hands-on training for ranchers and land managers, helping them use unmanned aerial vehicles to improve operations. The program also supports the Utah Legislature's Great Salt Lake initiatives by using remote sensing to track water levels and guide policy decisions. Additionally, UdahView offers interactive learning experiences for students in rural communities that are near and dear to me and across the state. Helping them understand how remote sensing impacts their daily lives is key to helping people make better decisions. These efforts are possible because of the long-standing Landsat partnership between USGS, NASA, and the Remote Sensing State Grants Program administered by AmericaView. This work strengthens Utah's economy and supports local decision-making. Thank you for all that you do for the Beehive State, and thank you for letting me be part of what you're doing remotely with a video. I wish I could be there in person.
The next member of Congress we'll hear from is Dusty Johnson. Now, Congressman Johnson serves as South Dakota's lone voice in the U.S. House of Representatives. He serves on the House Agriculture and Transportation and Infrastructure Committees, as well as the Select Committee on the Strategic Competition between the United States and the Chinese Communist Party.
Hey everybody, Congressman Dusty Johnson from South Dakota. Thank you for learning more about AmericaView. It's critically important. You think about the major problems of our era, the things we have to tackle, the problems we have to solve, from agriculture to land use to economic development. You simply can't address those issues without good data, good information. And that's where AmericaView comes into play. You learning more about the exquisite capabilities of these programs is going to help make you better policymakers, and it's going to help make your bosses better policymakers as well. Now, there's a key role for Congress here. None of this would be possible without the critical 53-year Landsat program partnership between USGS and NASA and the Remote Sensing State Grants Program that is administered by AmericaView and its member states. These new technologies build on those long-standing technological platforms, the old and enabling the new, allowing us to solve all these great problems. So listen up, take good notes, learn lots, and thanks for your interest in this program.
And finally, we'll hear from Congressman Nick Begich. Congressman Begich is serving in his first term in the U.S. House of Representatives, and among his committee assignments in the 119th Congress, he sits on the House Natural Resources Committee and currently serves as the vice chairman of the Energy and Mineral Resources Subcommittee and the vice chair of the House Subcommittee on Railroads, Pipelines, and Hazardous Materials.
Hi, Congressman Nick Begich here. Just wanted to take a minute or two and welcome you to the AlaskaView briefing. I want you to understand the work that you do is so important to the future of our state, whether that be in wildfire mapping or critical minerals mapping. The work that is done by your team is used by people across industry. It's so important that we continue to develop the capabilities that we have, whether that be through orthorectification, LiDAR technology, or other remote sensing packages. We need to make sure that we have a super spectral data set for the state of Alaska over time. The Landsat Next program is going to help supplement a number of the artifacts that your team has been producing. And I'm very excited about that work coming in 2030, 2031. I want you to have a great briefing. I hope things go well. We're looking forward so much to the work that you do, and I thank you for that. This is Congressman Nick Begich.
All right. Well, we would like to offer a great thanks to our congressional speakers because we very much appreciate all that you're doing in Congress in your work with the USGS, with NASA, with AmericaView, and with our StateView partners to make effective use of that actionable data from that 53-year Landsat program that was mentioned there by Congressman Johnson, followed up by Congressman Begich, in that, as a colleague of mine says, Landsat is the world's only legitimate time machine, having a 53-year archive of viewing the Earth over all of that time and be able to look at what's been happening and change over time within these areas. It's a huge tool at helping to promote economic growth and for strengthening the domestic workforce and for protecting our communities. But anyway, our next speaker here is going to be Chris McGinty, who's the Executive Director of AmericaView and the Assistant Director of the Remote Sensing and GIS Laboratory at Utah State University. And he's going to be providing an overview of AmericaView's mission, the importance of remote sensing and Earth observation, and a summary of this whole USGS NASA Landsat program.
Thank you, Brad. Good morning and afternoon to all of you. As Brad said, my name is Christopher McGinty, and I have the privilege of serving as Executive Director for AmericaView through my role at Utah State University in Logan, Utah. I'd like to extend a special thank you to each of our congressional members and their staff who took the time to discuss the work done in each of their states, the importance of AmericaView as a program, and certainly the critical role the USGS National Land Imaging Remote Sensing State Grant Program plays in fostering Earth observation and remote sensing. I also want to reinforce the importance of the 53-year Landsat partnership between USGS and NASA, which has allowed America to be the global leader in remote sensing. Landsat has allowed us to map and track our critical resources and keep a close eye on the pulse of our planet for over 5 decades, an incredible amount of time. We look forward to continuing that mission through the launch of Landsat Next in 2031. I'd also like to thank Liz Powell and the team at G2G for their efforts to help us foster and spread the message of why remote sensing is powerful. Next slide, please. The AmericaView network was established as part of a congressional mandate in 2003, as Brad mentioned, for AlaskaView program that was established in the late 90s, which was really established to promote the use of Landsat data at a time when the data's power was just beginning to be realized. And from that one state, AmericaView has now grown to 37 full members and 5 associate members. We're really pleased to have recently welcomed Florida Atlantic University as the home of FloridaView and our 42nd State View member. Next slide, please. AmericaView is a nationwide, university-based, and state-implemented nonprofit. The strength of AmericaView is in the national organization that uses the power of remote sensing to focus on local issues, a powerful investment in each of our states. The pictures that you'll see on the screen are just examples of only a few of the thousands of projects that have been completed and continue as we meet today. IdahoView, whom you'll hear from today, has done fantastic work addressing local issues and providing student opportunities, and has been recognized by Representative Simpson's office on a number of occasions. Programs such as those developed by LouisianaView, including partnerships with other programs like the NASA Air and AeroCats program, as well as LouisianaView's 25 years of training geospatial disaster first responders through key local, state, and federal partnerships. UtahView, supporting the education of ranchers, land managers, and rural students, as Representative Malloy stated, in the use of remotely sensed data to improve land management and efficiency. WyomingView, one of the original members of AmericaView, encourages students to learn the importance of remote sensing and Earth observation through place-based learning, such as the example of Jake Disney, who you'll see on the screen, who used Landsat data to improve operations on his family's ranch in the Powder River Basin of Wyoming. And MarylandView, who's worked with students to understand the importance of remote sensing through multi-day learning opportunities and engagement with NASA Goddard Space Flight Center and others. These are just a few of the activities and examples of AmericaView members that have undertaken to unlock the power of remote sensing. Next slide, please. So I keep talking about remote sensing and Earth observation, and while I haven't defined it, I'm sure most of you have kind of concluded that remote sensing is the use of data to help study our planet for various purposes. Without giving an hour-long introduction or lecture on remote sensing, we can really summarize this by stating that remote sensing is observing an object or phenomenon from a distance and collecting data about that phenomenon, or using a platform such as a satellite, an aircraft, a drone, or UAV that has some sort of a sensor on board. The bottom right, you've seen an example, the expansion of Las Vegas and the water levels in Lake Mead as captured by Landsat from 1972 to 2023. This 50-year record of the changes in the surface of our planet is incredibly powerful, incredibly valuable. Next slide. I want to mention a few of the benefits of remote sensing, and this is just a few of them. There's many more. But remote sensing really enables us to access perspectives of our planet, typically reserved for those with wings. It helps us tackle challenges that we would otherwise face with a limited viewpoint standing on the ground. Remote sensing enables us really to develop problem-solving and critical thinking skills, as well as building capacity that strengthens us as individuals, communities, and as a nation. Remote sensing also has a key role in making sound decisions that help us foster safety and security by mapping and maintaining our resources. It also helps us identify threats, issues, or other problems that we may not otherwise see by simply just standing on the ground and looking around. Remote sensing and Earth observation really enable us to unlock career pathways that foster innovation and technological workforce of the future as well. These are just a few of the benefits, as I stated before, but they really truly touch nearly every part of our society and economy. Next slide, please. Before I turn the rest of the briefing over to those individuals who are really making the difference by addressing the local issues in their states through remote sensing and Earth observation, I want to offer several comments about the impact and future of the Landsat program. Landsat 1 was launched in 1972. It was a dream of a small number of individuals that the U.S. would have a satellite in orbit to keep a watchful eye on the planet, not just the United States, but the entire globe. Over 53 years later, we now have Landsat 9 in orbit and collecting imagery even as we meet right now. That imagery is being downloaded and processed by the USGS Aero Center in Sioux Falls, South Dakota. An incredible number of folks there work to maintain the Landsat archive, which is the longest running satellite record of the Earth's surface. And it's critical in contributing $25.6 billion to the economy in 2023. This program valuation is led only by a small number of other satellite systems, including GPS and the NOAA weather satellite constellation. Landsat is unique in its operational partnership between USGS and NASA. NASA builds and launches the satellites, while USGS takes operational control once they're in orbit. USGS has developed the infrastructure to download, process, and distribute the raw data and key critical derivatives of that data from the AROS data center. Since 2008, Landsat data has been freely available and easily to access to the commercial industrial entities, researchers, and the public. Landsat data serves a key role in industry and commerce. Commercial satellite companies use Landsat data as the gold standard to calibrate their instruments once they reach orbit. Other folks, such as individuals looking at agriculture features, use Landsat to help make crop predictions. The United States uses the data to map and track critical resources here in the U.S. and across the globe. Disaster responders use the data to evaluate widespread impacts of hurricanes, tornadoes, fires, and more. Landsat is a key national asset and resource, and it fits a niche that serves the public, commercial, academic, and private interests. So the Remote Sensing State Grants Program, which we've heard of from our congressional members about, is the grant program through the USGS, the United States Geological Survey, National Land Imaging Program, that has been competitively awarded to AmericaView as its steward. AmericaView's vision and mission has long been built around remote sensing and Earth observation, but even more than that, fostering the use of Landsat and other remotely sensed data to address local issues and provide opportunities to students, researchers, educators, and businesses to use that data. The grant allows AmericaView members to develop key technological and educational resources that meet the needs of their state. Many of the educational resources are closely tailored to the state-based education systems, community needs, and local environment. There are many examples of this, but two that come to mind are the work done by DelawareView and TexasView, which you can find on the AmericaView website at americaview.org. AmericaView and its members work locally to unlock and share the power of remote sensing and will continue to do so in order to address key issues and possibly more important, to foster the technological workforce of tomorrow. Next slide, please. Part of that continuation of the service and opportunities that AmericaView provides to the Remote Sensing State Grant Program is based on the future of the Landsat program. Landsat Next is the next iteration of the 50-year Landsat program. It's already in development, but always could use a little extra boost and support from our congressional members. Landsat Next will be composed of what has been termed superspectral triplets. So Landsat Next isn't going to be a single satellite, but three smaller, efficient satellites operating together to improve revisit time over any spot on the Earth's surface. The system will have an increased ability to view what's happening on the Earth's surface through improved resolution and the ability to image different parts of the electromagnetic spectrum not currently available from Landsat 9. There's some key language there, but it should suffice to say that we're super excited, very excited, about Landsat Next and the superspectral triplet architecture. Next slide, please. So I'm really excited for you to hear from our panelists. They've all prepped for today and been doing a lot of their work for a number of years. Each of them have a mission and vision within their state to unlock the power of remote sensing and Earth observation. AmericaView is going to continue to work for each of you to build the United States' remote sensing technological and educational capabilities through outreach, education, applied research, workforce development, and technology transfer. Thank you for your time. Thank you for joining us today. And back to you, Brad.
All right. Well, thanks so much, Chris. As Chris mentioned, next thing we're going to be turning is to our State View presenters. Now, we have an all-star lineup that's ready for you here for this afternoon, and each of our presenters is going to be showing you some kind of case studies on how that they're using remote sensing and this Earth observation techniques in order to prepare the workforce for the future, but more importantly, how they're going to be responding to local needs. Now, our first speaker here is going to be Dr. Donna Delparte, who is a professor at the Department of Geosciences at Idaho State University. Obviously, she's going to be representing IdahoView, and she'll be sharing her perspective on how support through AmericaView is going to be training the next generation of young people in cutting-edge remote sensing technology, which is going to be related to mapping landslide potential, and landslide potential more specifically along transportation corridors and monitoring thermal conditions in stream systems. That's going to be looking at spawning salmon and red band trout. So take it away, Dr. Delparte.
Thank you very much, Bradley. At IdahoView, our focus is partnering with industry, public sector, private sector to find solutions for Idaho, and all the while training the next generation of remote sensing experts. Next slide, please. As part of that, one of our main issues in Idaho is looking at landslides along transportation corridors. Here's a few incidents that happened on a rail corridor in northern Idaho, where we had train derailments due to landslide activity undermining these transportation networks and creating derailments. So we can use remote sensing to actively monitor and check out any kind of susceptible areas in advance before something happens. Next slide, please. So in this example that I'll provide today, we'll look at these railway corridors and how we've been using unmanned aircraft systems to fly them and using advanced remote sensing systems to gather information about these susceptible slopes. This is an older project from 2017 and 2021, and we've continued working on this across not only rail corridors, but also for highway corridors as well. Next slide, please. This is an example of some of the advanced sensing systems that we use. This is something called LiDAR. And here you can see up on the top bank, there is a railway corridor. And this is where we saw that train derailment. And what we can do here is by looking at this LiDAR data, we really want to look underneath all of this heavy forest and see what's going on with the land surface. LiDAR is a really powerful tool, not only for kind of looking through and peering through forest canopy to find out what's going on underneath, but we can actually also use LiDAR for managing forest systems. Even in this example here, doing a count and survey of how many trees would be in this area. Next slide, please. So in this example, here is that same area, and we've stripped away the trees. So here we can see that railway corridor on top, and very briefly, if you can kind of look over the kind of left-hand section there, you can see where the railway corridor was undermined and where those trains were derailed. So by monitoring these systems, we can start looking for other susceptible areas and identifying them before something happens, especially along our sensitive river corridors here in Idaho, which are so wonderful for recreation and other purposes for Idahoans. Next slide. So here's an example of a student project where they started to identify those susceptible areas and can start thinking about what are some ways of stabilizing slopes and looking at preventative measures. Next slide, please. And we also started applying this along roadway corridors. And here you can see a susceptible area along a highway. And on the right, top right, is a sequence of images looking at kind of peering underneath the vegetation and looking at what's going on. So starting in 1987 and going to 2024, we can see movement of material along the susceptible corridor. And if you look at the collapse feature, you can see this little hole popping open over time. There's a scarp that starts to widen. And then in the bottom section, we're starting to see some movement of material at the bottom that is impacting the highway. So being able to kind of go back in time and use remote sensing to look at what's going on has really been a powerful tool. And for this project, the highways, working with Idaho Highways, they were really surprised to see some of the features popping up here, especially that collapse feature. That was a surprise to them. So being able to kind of alert our highways and management people for transportation corridors really is a powerful tool. And training students how to do this means that they are getting snapped up into jobs. And the students that I have working for me barely finish their degrees and they are off to the workforce. Next slide, please. We've also been doing a lot of work with monitoring salmon spawning streams, in particular in partnership with Shoshone-Bannock tribes, and looking at a place near Stanley, Idaho, along the Elk Creek and Bear Valley Creeks. And on the left-hand side, you can kind of see these hot spots or kind of pinky orange spots. And that's where we see a lot of salmon returning and spawning in the stream system. So the brighter the color, the more spawning salmon locations have been identified. On the right-hand side, you can see, we can kind of peer through the water and look at these slight depressions where salmon are building their nests for spawning. So the salmons come along and they make some movements in the stream bed and create these spawning beds where the fry will hatch. So we've been looking at these stream systems, again, with using unmanned aircraft systems and training students how to use drones and collect data that's relevant for stream management. Next slide, please. So we'll go through a series of slides here as we kind of dissect the stream and look for these different characteristics of where salmon are spawning. You can see the yellow dots, and those yellow dots represent little nests that the salmon have built in the stream network. So we can kind of look at what is the riparian or the vegetation around the stream looking like. What is the surface of the stream bed for the bathymetry? Next slide. We can examine the depth. How deep is the stream? What is the depth that salmon are typically building those nests in? Next slide. We can look at how steep is the gradient for the stream. Next slide. And then we can look for velocity, not only the speed of the stream, but also looking for things like little eddies, which make for great fishing spots in stream systems. Next slide. And then finally, something that's been of concern is looking at suitable temperature ranges to ensure the growth and survival of the fish fry, and really identifying what temperature regimes salmon are preferring to build those nests in. The nice thing is that we can do these surveys without any disturbance to the fish and minimal impact of any kind, but looking at things and changes over time. So part of the Shoshone-Bannock tribes is looking at long-term monitoring and looking at those thermal refugia for fish fry. Next slide. And then finally, it wouldn't be Idaho without potatoes. And in Idaho, we're very interested in working with farmers and growers to help them address a critical issue called potato virus Y. Potato virus Y is really hard to detect with the naked eye. And so we are using remote sensing to put on kind of like goggles where we can see plants that are infected. And we are working with industry partners on this one because we've identified a sequence of bands, or almost like glasses, that you can put on and identify plants that are sick, where to the naked eye you could not see which plants are infected. So that is something that we're really hoping that will contribute to the economic benefit of Idaho and benefit of all Idahoans in support of our agricultural activity here in the state. Next slide. I think that's it for me. One last thing, just working in Idaho has just been a real pleasure with all our excellent partners from around the state. And thank you very much. And back to you, Bradley.
Thank you, Donna. And again, for our audience out there, remember, if you have any questions for any of our speakers or for Chris or for any of us, please make sure you put them in the Q&A box and we will answer them here once we get to the Q&A portion. Please don't put them in the chat. We'll be able to get them from the other locations. But anyway, our second speaker is coming to you from South DakotaView, and that's going to be Dr. Bruce Millett, who is an assistant professor in the Department of Geography and Geospatial Sciences at South Dakota State University. And he's going to be discussing how remote sensing is used for precision agriculture within South Dakota. And he's also going to highlight some of South DakotaView's training and outreach efforts.
Great. Thank you, Brad. Good afternoon, everybody. I would like to start my presentation by discussing the importance of agriculture in my state. Go to the next slide. Agriculture accounts for around 25% of the state's GDP, and about 53% of the farms use precision agriculture technologies currently. These technologies, they monitor crop health, they detect diseases and pests, and they manage soil moisture. Precision monitoring, it minimizes unnecessary treatments and reduces waste, saving money and resources. Next slide. Our stakeholders include farmers, agronomists, research institutions like South Dakota State University, state government agencies, federal government agencies, consumers and retailers. Federal agencies like USGS Aero Center are critically important in this area of remote sensing research. Currently, we integrate Landsat data into several of our AI models. Next slide. Typically, farmers get crop yields after harvest. This allows farmers to get yield, or this project allows farmers to get yield predictions earlier. We're talking maybe weeks or months in advance. And our research can be divided into three main areas. The first involves early crop yield forecasting using remote sensing. As shown here on the map, we monitor several study sites in South Dakota, and we collect about 3 to 4 terabytes of high-resolution drone imagery annually. Analysis from these images provide early crop yield forecasting. These help optimize agricultural practices, enhance food security, and provide timely, actionable insights that benefit farmers, governments, and markets. Next slide. The workflow diagram on the left, this shows the steps to process and analyze image data through our AI models. The models show adequate results currently with a 65% yield accuracy, 61% protein prediction accuracy, and a 69% seed test weight prediction accuracy. Also, currently right now, South Dakota State University winter wheat breeders are now testing these models for high yield wheat variety selections. Next slide. These two diseases are quite common in U.S. growing areas. Farmers, they can treat infected areas early by detection, reducing harvesting, improving crop management, increasing yield, protecting the environment, and ensuring food security. Our AI models use multimodal data fusion to estimate crop disease severity, integrating data from diverse sensors, imagery, and environmental sources. This helps improve precision and effectiveness of disease detection and severity estimation. Next slide. The severity map shows green equals healthy wheat, yellow equals mild to medium severity level of disease, and red equals high severity level of disease. Results from our analysis show that Fusarium head blight prediction had an accuracy of 78%, and wheat bacterial leaf streak had a prediction accuracy of about 82%, which were pretty good. Next slide. We use high resolution drone data to derive crop canopy coverage and density information and use it to train satellite-based models. We can obtain very accurate crop canopy coverage and density information for each satellite pixel footprint. Those are outlined in blue on the right. Once the satellite data has been trained, we no longer require drone imagery, which was used for ground truthing. The end product results in map pixel values to crop canopy coverage and density information. Next slide. A true color image is shown on the left, and the predicted canopy cover is on the right. Now, canopy cover here is essential in the precision agriculture because it provides a visible, quantifiable indicator of crop health and productivity. By monitoring canopy cover, farmers can make informed decisions about irrigation, fertilization, pest control, and harvest management, leading to more efficient and sustainable farming practices. Understanding and managing canopy cover allows for better resource allocation, improved yields, and cost reductions. Next slide. For our training and outreach, we have conducted Drones for Educators and South Dakota's Art workshops for K-12 teachers. We have also provided drone training workshop for more than 70 tribal members at Ogallala Lakota College and Lower Brule High School. Next slide. Some of the conferences and events. The Big Sioux Water Festival is a science fair held annually. We collaborate with Aero Center to educate students about remote sensing. Last year, more than 1,100 sixth grade students attended the festival. And this year, more than 1,200 fifth grade students will attend. We participate each year at the South Dakota State Geography Convention, providing remote sensing information and evaluating student research. Another important event is the biennial South Dakota Geospatial Conference. I serve on the planning committee, which assembles geospatial technicians from around the state. Through this conference, we share our work, knowledge, and insights related to geospatial technologies, data, and applications, including GIS, remote sensing, and spatial analysis. Drone Day is another event closely tied to SDView, where we provide presentations and we also do conduct drone training. Lastly, I would like to state through our SDView grant, this year we were able to partially fund the continuing research for one PhD student dissertation and one master's student thesis. Thank you, and back to you, Brad.
All right, thanks so much. Our next up at bat is Dr. Santosh Panda, and Dr. Panda is going to be representing AlaskaView, and he's going to be providing an overview of AlaskaView's efforts in advancing geospatial research in the area of forest health assessment and wildfire mitigation within the state of Alaska. He'll also be talking about growing open access educational resources and enhancing public awareness of the importance of geospatial science and technology for societal well-being. So take it away, Dr. Panda.
Thank you, Brad, and thank you for the opportunity to share my team's research here today. I'm Santosh Panda. I direct and manage the activities of AlaskaView. Next slide, please. So Alaska is the largest state in the country. It has 126 million acres of forested land, which is about 35% of the state's total area. U.S. Forest Service Forest Health Protection Program, they do conduct aerial surveys to monitor forest every year. But given the vast size of our forest, as well as shorter summer window, they can only cover about 15 to 20% of the forested area. So that makes a strong case to use remote sensing to monitor forest in Alaska, including forest health, insect infestation, forest loss due to wildfires, and so on. So our goal is to advance remote sensing research of forested ecosystems to support forest health protection, effective forest management, and aid wildfire mitigation in the state of Alaska. Next slide, please. Here I'm showing some results of a forest greenness trend analysis. On the left, you see the study area, where the study area is located. It has a few different kinds of topography, upland, lowland, and floodplain. Also, there were fires that happened at this site. The middle figure represents how the vegetation has been responding through time. And the trend analysis shows that we're seeing mostly greening in this particular study area with some browning. So the orange and red color represents browning in this middle figure. And then the other thing that we are seeing is that within the fire perimeters, we're seeing more dominant greening. Again, that shows that right after the fire, the trees come back within a few years, and they keep growing. And in about a few decades, they actually recover back to the pre-fire stage. And the right figure represents the strength of that trend. Next figure, please. So for one particular fire that happened in 1983, Rosy Creek Fire in that study area, we also looked at how long it takes for a burn site to recover to the pre-burn state. And what we are seeing here is that it's in about like 30 years, the burn site, they pretty much have the same level of photosynthetic activity compared to the unburned site. So this sort of information is really helpful to understand the overall carbon budget and post-fire recovery at a given site. Next slide, please. Now I'm going to share a little bit about the wildfire research. So these two photographs show the start of a wildfire near the entrance of Denali National Park and Preserve. I camped there 2 nights, and while exiting the park, actually this fire started. So I took this picture from my car, so I'm behind that bus. And this drives home or underscores the threat from wildfire to people who live in urban wildland interface. Next slide, please. Just a little bit about the wildfires in Alaska. The left figure shows where we usually get wildfires. It's along a belt we call Interior Alaska that is bounded between 2 mountain ranges. In the south, it's Alaska Range, and in the north, it is Brooks Range. And the different colors represent the fire polygons from different decades. The right graph represents area burned in a given decade, and the blue line represents the number of fire counts. So what we are seeing here is that in the last 2 decades, both the area burned from wildfire as well as the number of fire counts have gone up substantially, and so as the threat from wildfires. Next slide, please. We also do research on mapping vegetation, which is the fuel for wildfires. So on the left, I'm showing a older product that is showing about 8 different vegetation classes in this particular site with a pretty low accuracy. So my team, we worked on developing a new improved algorithm to map detailed vegetation from hyperspectral data, which is, again, a more enhanced data set compared to some of the multispectral data set. And we're able to map 20 different vegetation, again, fuel at this particular site with about 95% accuracy. Next slide, please. So using this new algorithm, we actually mapped vegetation for the whole boreal Alaska. The figure here shows just one tile that represents 100 kilometer by 100 kilometer area. We're able to map 16 different vegetation classes. Also, we came up with a ArcGIS story map where we have hosted this product so that wildfire research community as well as interested public can access this data. Along with that, we also built a app that interested researcher can use to take a Sentinel-2, which is a which is a multispectral image, and convert that into Everest-NG, which is a hyperspectral image for their application of interest. Next slide, please. We also looked into mapping needle-leaf fraction or conifer fraction. So conifer vegetation tend to be way more flammable compared to the other vegetation that we have here in Alaska. So it makes sense to have more detailed information about the distribution of conifer or needle-leaf. So here I'm showing some results from how do we actually get conifer fraction at a given site, which is again extremely helpful when the fire team is dealing with an active fire or planning to mitigate future fire events. Next slide, please. Using support from AmericaView, we also developed several open access geospatial courses that are hosted on edx.org. Again, here our goal is to introduce GIS and remote sensing science through natural resources and wildfire applications. These courses have so far attracted 50,000 plus enrollment, and they're available open access. A lot of our learners are university students, state and federal agency employees, general public. Okay, next slide, please. We also participate in local and state level outreach events. Here again, our goal is to enhance public awareness of the importance of geospatial science and technology for societal well-being. We have a state puzzle that we bring to these events. We also developed a Alaska as Art exhibit that we bring to these events. And a lot of these events actually attract family with K-12 students and science enthusiasts, and sometimes the general public in a community. And so we have been, regularly participating in many of these events to again, share about our research as well as the impact of remote sensing for societal well-being. Next slide, please. With that, I thank you for the opportunity again to share my team's research here today. Thank you.
All right, thanks very much. And batting cleanup here today is going to be our final speaker, Dr. Yuting Zhou, who's an assistant professor and the co-director of the Center for Applications of Remote Sensing in the Department of Geography at Oklahoma State University. So he'll be talking about what OklahomaView is going to be doing with remote sensing in agriculture and natural resource management by looking at winter wheat mapping, logging activities monitoring, and also woody plant encroachment assessment.
Thank you, Brad, for the nice introduction. As it was mentioned, my name is Yuting Zhou. Today, I'm going to focus on the usage of remote sensing in agriculture and natural resource management with case studies in the state of Oklahoma. Next, please. So here, if you can see, I'm showing you an animation which we call the NDVI. NDVI is something we use in remote sensing to indicate plant health or vegetation health. The greener the color, the higher the NDVI values. So here I'm playing an animation. We are having one image every 16 days. That means one image for the January 1st until January 17th. And then the next 16 days, we are going to have another image. So each of the image is played for 2 seconds. Now let's focus on some of the interesting areas. If you see this blue colored area, we see it is green actually in winter. And then it stays green until January, February, in March, and it becomes very green in the late March and the April period. And then all of a sudden, when we get into by the late of May and the early of the June, it becomes white color. That means the vegetation or the plants are gone. So then we know why that happens, because we have something special there that is green in the winter, but it gets harvested in May or early June period, which is winter wheat. And now let's zoom into the second study area, which is the red square indicated area. We can see this area is the southeast of Oklahoma. See, we can see this area is pretty dark green almost year round. So if we think about what is going to be always green in for the whole year, which is going to be the evergreen forest. So just using something as simple as what we call the NDVI, which is the indicator of the vegetation health, we can use it to identify winter wheat and the evergreen forest in Oklahoma. Next, please. And besides showing only one of the time series of the NDVI, that means every 16 days, we can also see the maximum of NDVI, basically the largest NDVI values for the year. So this, which is a good indicator of the peak growth of plants. So every year we can get a maximum of NDVI. And if we see the dynamic of the maximum NDVI, you can see this actually reflects the best vegetation growth throughout the year. Can we play the animation again? And then if you can notice the trend of the maximum NDVI in the state, you can see there is a very clear pattern that on the west side of the state, we see a lot of dynamics in terms of the color, this green color. However, in the east side of it, it does not change much, which means drought mostly affects the western part of the states. Next, please. And in Oklahoma, we also did something we call the Oklahoma as art, which in this activity, we selected the representative places in Oklahoma to show how the area has been looked like, can be viewed by satellites. Here we show the Landsat image of the largest lake in Oklahoma called Lake Eufaula. We can see the lake area and the urban areas and also the very green vegetation on the southeast region of the area. And besides on showing the Oklahoma as art, we can also compare the same places appeared in two different periods. Next, please. So when we see the same area, here we are showing you another Landsat images, which is the false color composite. The red color means vegetation in this situation, and the white areas means urban areas or bare soils. If we zoom into one of the major focus area, which is indicated by the yellow box, we can see on the left side, which is 2014, we have a lot of red color. But however, when you see the happens in 2023, we see quite a lot of gray color or white color areas, which was showing the logging activity. However, now let's zoom into the second focus area. You can see this area in 2014. So there was a lot of gray color scale. That means there's a lot of bare soil. However, after we cut the trees, we plant the new trees, and then after about 10 years in 2023, we can see the area becomes pretty red again, which means the trees regrowth. Next, please. And besides showing only one of the areas, we can also zoom into specific areas of the agricultural activities. This is showing a place in southwest Oklahoma, showing the period of May to October, captured by Landsat. You can see quite a lot of agricultural activities going on, indicated by the color changes in those regular plots. So next, please. And besides that, we can also use these Landsat images to study something we call the woody plant encroachment in the region. So woody plant encroachment is a very important issue for the state of Oklahoma. We are facing this the threat of woody plant encroachment into grasslands, which threats livestock industry. In this time lapse, what I showed is this deep green color indicates the areas of the woody plant encroachment. We can see across the different years, there is more and more of the deep green color areas, which is showing the woody plant encroachment. Next, please. And if we zoom into one of the hotspot areas of the woody plant encroachment, you see in the panel of the ABC, which are the years of 2004, 14, 20, 24. You can see there are more and more of these juniper trees encroached into the grassland areas. I think that's all of my presentation. Thank you for your attention. Back to Brad.
All right. Well, thank you so much to all of our speakers here today and for joining us here this afternoon. We hope that their presentations have allowed you, the audience, to watch the curtain pulled back a little bit on here is just really what remote sensing is and what it can do, particularly with satellite data and drones being used in the private sector and the government for driving local decision making, and also for the important role that Congress plays to ensure that AmericaView can continue to prepare the highly skilled workforce of tomorrow. But before we sign off, we'd like to open the floor up for any questions. We've seen some questions coming in from the Q&A box so far, and we wanted to address as many of those as we can before we wrap things up here. Our first question was coming here to us a little earlier today from Herb, I hope I'm not mispronouncing your name, Fineweaver. I hope I didn't mispronounce that, who says, how can citizen scientists contribute to ground-based data to help with validation of remote sensing data? I'm thinking of feeding ground truthing into algorithms that produce thematic land cover maps, for example. And I wanted to kick this question over to Chris, who can address this for us.
Sure. Thanks, Brad. Herb, that's a great question, and I can answer it fairly quickly, and we can talk more offline if you'd like to email me. But I'd say one of the best ways to help with validation of remotely sensed data is get involved with the NASA GLOBE program. You can go to the GLOBE website and look up their land cover efforts. But certainly that's an excellent way to do citizen science contributions to validation data for remotely sensed data, or remotely sensed data products, I should say. So head over to the NASA website and check out the GLOBE program.
All right, thanks, Chris. Our second question here was from Benjamin Crawford, who says, how many satellites currently generate Landsat data? Do they piggyback off of GPS systems or others like Starlink and Beidou, or data at all? I can quickly just answer that we've had a Landsat satellite up in the sky since 1972, but at present we have both Landsat 8 and Landsat 9 in the series are the ones up there collecting data, and that's going to pave the way for those superspectral triplets, the Landsat Next satellites that are coming around. GPS, Beidou, they're all about navigation, and Starlink's about communication, so it's going to be those particular satellites. Right now, only 2 of them, with the superspectral triplets of Landsat Next coming, that are going to prepare that Landsat data. Our next question we have here is going to be, if LiDAR can track stream depth and speed, could it be used to supplement stream gauge data or just completely take over the job of a stream gauge? I know stream gauges track water quality as well, so I'd imagine they'll still be very important as they're always tracking data. And I believe Chris can kick this one over to him as well.
I do. Donna provided a great answer to that, and I'll just piggyback on hers, and Donna, you can chime in, but also wanted to mention, the USGS Stream Gauge network is an incredible network that has been around for many, many, many years. And the cost of, switching that over for data processing, putting in new equipment, LiDAR, various types of things that would have to be used would be pretty substantial. And so, we shouldn't diminish the use of a physical stream gauge on the ground or in the river, so to speak. So that's a really good question. But Donna, did you want to contribute some of what you wrote there?
Yeah, sure. The nice thing about those stream gauges is that once we survey an area and have that baseline data, we can simulate any kind of situation and pull from the stream gauge current situations and do some forecasting and prediction. So those stream gauges do come in handy and do provide some very useful information.
We have a question from Jeff Bland, which is a question straight for you, Donna. How is stream bathymetry derived from your USA flights?
So that river system that we were flying over was a beautiful, clear water. You could visually see right through the water, and with an RGB camera, just a regular good quality camera, we could use some image processing magic and take the remotely sensed data that we collected with the drone, collecting those camera images, and stitch them together and create the map. And then we applied a little correction factor for the refraction of water to make sure that our stream bed data was correct and accurate. For deeper water, we do have to go to something called a green LiDAR system that can penetrate water and get that depth information. Hope that answers your question, and I'd be happy to follow up with you anytime if you want to talk further.
Well, unfortunately, I see by the clock on the wall that we are out of time. If there's any other questions that we weren't able to get to, we would be happy to follow up with you here. And also remember, we'll be sending out the link from today's recording, and we're looking forward to working with you to ensure that all 50 states have the necessary resources for working here with remote sensing. Because that's what we'll be doing here with AmericaView, is going to be looking at training that next generations of innovators, business leaders, and problem solvers for the workforce of tomorrow. So thanks very much for joining us today. And remember, I'm Dr. Brad Shellito, and we are AmericaView.